Welcome to Algebra 2. We got section 4.2 today, adding, subtracting, and multiplying polynomials. All right, for our introduction, we are going to find each product. Remember, the product is the result of multiplication. So this is a review of skills that we should know already. So I want you to pause the video, take a minute or so, and see if you can't find the product, and I'll be back in a few seconds to check our work. Okay, hopefully by now you've come up with some products here. So what we're doing is we're multiplying quantities. So here we've got the quantity a plus b times the quantity a minus b. And this is indicative of the FOIL method. We're multiplying two binomials. Those are expressions containing two terms. Multiplying two binomials together. We take the first term times the first term, the outside terms, the inside terms, and the last terms. We take each of those products. Then we notice that we can combine the like terms in the middle. In this case, they cancel. So our product is a squared minus b squared. For number 2, here you'll notice that situation, a binomial raised to a power of 2. And I've kind of casually mentioned the shortcut for this. It's the first thing squared, plus 2 times the first times the second, in this case 2ab, plus the second thing squared. We're going to explain where that comes from in just a bit. But we could have also FOILed this out. Something squared means that quantity times itself. And it becomes another FOILing problem. First times first, our outside terms, that's a times b. Inside terms, a times b again, and last times last. When we combine like terms, there we get our answer. Number 3, our shortcut method would tell us a squared minus 2ab plus b squared. Let's see what FOILing gets us. First times first, outside terms, inside terms, last times last. It's a negative times a negative, so it's plus b squared. Sure enough, our shortcut works. Now a plus b to the third power, this is the new one. We got a plus b times a plus b times a plus b. This time that quantity is multiplied by itself 3 times over. All right, well, what we want to do is take the product of 2 of those, right? We know how to FOIL those together or use our shortcut. And we already did a plus b squared up above. So we know that that's equal to a squared plus 2ab plus b squared. And then this whole thing, this whole expression can be distributed. So what we'd have is a squared times a plus b plus 2ab times a plus b squared times a plus b. So the distributive property helps us out there. And you can see already how much more involved raising this to the third power is. We've got much more distribution and combining of like terms to take care of. So a squared times a is a cubed. A squared times b is plus a squared b. I'm going to keep the variables in alphabetical order when I multiply them together. If I have 2ab and I multiply in another a, that's 2a squared b. Then I've got plus 2ab squared plus ab squared plus b cubed. Just want to make sure that we handle every distribution there before we start combining like terms. So I end up with a cubed. These are like terms, these a squared b terms, so plus 3a squared b. These are also like terms, 3ab squareds, and then plus b cubed. Now that was a very long process, and we are going to learn a way to streamline that approach. Just like we had a little shortcut here, we have rules for raising binomials to any power, really. But yeah, just a refresher, distributing, combining like terms, and the FOIL method, of course. All right, so today we've got three key things that we're going to look at. First of all, if we're adding and subtracting polynomials, it's all we're doing is combining like terms. So we just want to make sure we account for all of the terms that are alike there when we combine. And we also may have to, if we're subtracting especially, we may have to distribute a negative. So we want to be careful of that. If we multiply polynomials, that's distribution that we're using, and we saw that in our introduction, simplifying by combining the like terms, and you could also add the FOIL method in there as well. And then this last little bit, Pascal's triangle. What this does is it's a really neat pattern in mathematics that lends itself to raising a binomial to certain powers. So like this first row, if I have a plus b, that represents raising something to the 0th power. It just equals 1. That's why it's a 1. Then the next row, if I have a plus b, that quantity to the first power, it's 1a plus 1b. So that's where these 1s come from. Then the next row represents a plus b, or any binomial really, to the 2nd power. I have 1a squared plus 2ab plus 1b squared. That's where the 1, 2, and 1 come into play. And the next row, we compare this to number 4 in our introduction. If I have a plus b to the 3rd power now, I would have 1 a cubed plus 3a squared b plus 3ab squared plus 1b cubed. So you can see what's happening is that first element of our binomial, it has powers that start off at the power we're raising the binomial to, in this case 3, and then those powers on a count down to 0, while the powers on b start at 0 and count up to 3. Meanwhile, the coefficients out in front come from this triangular pattern. Okay, now let's say we want to continue this process further. Well, how do we keep this pattern going in the triangle? Where are these numbers coming from? Well, it starts off with these 3 1s at the top. And then to keep adding rows, we begin each successive row with a 1. And then the next numbers are found by adding up the 2 numbers up above. So 1 plus 1 is 2. And then we end each row with a 1 as well. So you can see here the 3rd row, or I guess it's the 4th row actually, but we start off with a 1, then we have 1 plus 2, then 2 plus 1, and then we end with a 1. The next row we start with a 1, 1 plus 3, 3 plus 3, 3 plus 1, and then we end with a 1. So if we wanted to generate the next row, we would start with a 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then we would end with a 1. And that's how we keep this pattern going. Very helpful if we're trying to raise a binomial to powers. Notice we didn't have to combine like terms in any of these little examples at all. Very helpful. All right, our first example. Here we're trying to find the sum or difference, so we're just combining like terms. So as I'm looking through this problem, I'm looking for the highest power of x first, right? We want to kind of set this up in standard form so it's easy to work with. So I've got an 8x to the 4th. Is there any other x to the 4th terms in that second expression that we need to add in? There are not. So 8x to the 4th. And I like to kind of cross them off as I've used them. Next, I'm looking for x cubed. Okay, I've got none in the first expression plus 3x cubes in the second. Okay, now x squareds, I've got 2x squareds plus a negative 5x squareds, that's minus 3x squareds total. And I've got, let's see, I just did x squareds, I should look for x terms first. We've got positive 7x. And now I've got a negative 1 plus a positive 1, those cancel out. So here is our sum. All right, for number 12, here we're taking a difference. Okay, so these two expressions are undergoing subtraction. So what I like to do personally is I like to distribute the negative. So if I distribute this negative sign, I get negative 14x to the 5th, positive 8x to the 4th, negative 11x squared, negative x, and then since it's been distributed, we can call that a positive sign. It just makes combining like terms much easier. The highest exponent I see is x to the fifth. I've got positive 4x to the fifth and negative 14x to the fifth. Combine those together, negative 10x to the fifth. All right, fourth powers, I've got positive 8x to the fourth. X cubes, I've got negative 7x cubed. X squared, I've got negative 9 and negative 11x squared. That's negative 20x squared. Now my x terms, I've got negative x. And then for my constants, I've got plus 18. Just combining like terms, there is the difference. And that's our answer. Number 20 here, for example 2, multiply the polynomials to find the product. Notice there's no sign in between. It's kind of tempting in these previous examples to try and start foiling things together. Check to see if there's a plus or minus sign in between first. If this is a much easier problem. Often students interpret, they see two things in parentheses and they say, oh, FOIL, and they try to do that right away. Make sure it's multiplication first. So in this case, we do have multiplication, so we want to use that distributive property. So I've got 2x squared times that first quantity. I'm going to distribute this entire quantity. So I've got 2x squared times negative x minus 3 plus 5x times negative x minus 3 plus 8 times negative x minus 3. And we just want to be very methodical here, make sure we're accounting for everything. Now we've got more distribution. All right, we got to take care of parentheses first, follow our order of operations. So I've got negative 2x cubed minus 6x squared minus 5x squared minus 15x minus 8x minus 24. And finally, we can combine our like terms. Negative 2x cubed minus 11x squared minus 23x minus 24. Really not a horrible amount of writing to do. Most of that's just to make sure we haven't left anything out. All right, for number 30, here this is just kind of repeated distribution multiplying together. What I want to do is, that last one was pretty manageable because we had a quantity, a binomial, to distribute into another one. So kind of like what we did in the introduction, I'm going to FOIL. I like to choose the second and third binomials here and multiply those together. So let's see what would happen if I FOILed those two together. I need something to distribute this 2x plus 5 into. So I would have 3x squared, and then my outside would be plus 4x, and then minus 6x, that's minus 2x total, and then minus 8 when I do last times last. So I kind of combined like terms on the fly there. This should be what we end up getting when we FOIL those last two binomials together. Now let's distribute that entire quantity. So we have 3x squared times 2x plus 5, negative 2x times 2x plus 5, and negative 8 times 2x plus 5. Distribute yet again. We get 6x cubed plus 15x squared minus 4x squared minus 10x minus 16x minus 40. One thing that's really nice about doing the distribution this way, off to the side here I'll show you another way that I've seen this multiplication done, but it makes combining the like terms at the end much more difficult, and it's really not any faster. I like the way that this organizes your x cubes, then your x squared, then your x's, and then your constant. It makes combining like terms at the very end much easier. So I'm just going to combine the like terms together here to arrive at the final answer. Now let's see what would happen. I just want to show you this other method. You may find it easier, you may not. But if we were doing this 2x plus 5 times 3x squared minus 2x minus 8. And what I've seen teachers do in the past is, and I've even taught it this way before too, is they say, okay, in your binomial at the start you've got 2x. You need to multiply that into everything at the end. So we would have 6x cubed minus 4x squared minus 16x. And then you need to do the same thing with the plus 5. So we have plus 15x squared minus 10x minus 40. And then you'd combine like terms and arrive at the final answer. You may see that as faster. I see it as about the same amount of work, but it's easier to lose negative signs and things when, notice here is this 4x squared and then the 15x squared, they're not right together. So, I mean, you can really take your pick. They both work equally well, but I like the distribution better. It makes more sense to me. All right, example 4, here we're finding the product again. All right, well, this first one, number 38, nice FOIL candidate there. First times first, 4y squared. Outside will be positive 10y. Inside negative 10y. Hey, those like terms will cancel. Last times last, negative 25. Now, I could have run through the whole FOIL method there, but hopefully we're picking up on some patterns. If we have the same factor, one with a negative, one with a positive, we're basically undoing a difference of squares. Factoring problem. Number 40, here we're FOILing this out. Let's use our new binomial expansion. We know that the coefficients go 1, 2, 1 because the second power indicates that we're going in the 0th, 1st, 2nd row of Pascal's triangle. So our coefficients are going 1, 2, 1. Then we've got 1 times the first thing squared. First thing is 9g, so if I square that I get 81g squared plus 2 times the first times the second, so that's 2 times negative 36g plus 1 times the second thing squared, 1 times negative 4 squared, which is 16. So we have 81g squared minus 72g plus 16. It's a very nice trick using that triangle when we don't have to combine like terms at the end. All right, and example 5, use Pascal's triangle to expand. Here you can see, wow, a 4th power. So let's expand out Pascal's triangle. 3, we want this one with 4. 1, 4, 6, 4, 1. The first thing in my binomial is NP. And the second thing is negative 1. So I've got 1 times the first thing to the 4th power. Then I've got plus, my next coefficient is 4. 4 times the first thing, remember we count down the powers, to the 3rd times the second thing to the 1st plus 6 times the first thing to the 2nd times the second thing to the 2nd. So you can see what we're doing with the exponents. The first thing in our binomial starts off at 4 and counts down. The second thing in our binomial starts off at the 0th power and counts up. Nice, easy pattern, but again, we want to be careful that we're not losing anything. This may seem like a lot of writing, but we're making sure that we don't lose anything in the shuffle. Okay, and finally, we get to the point where we've expanded that out. We have our patterns happening with the exponents. Now it's just time to clean this up. Now we don't want any parentheses, and we don't like these negatives raised to a power. Remember, each one of these products is going to be one term in our polynomial. So we want to be sure that they are grouped together and they don't have multiple positive or negative signs in there. So the first one, if I take np to the 4th power, that's n to the 4th, p to the 4th. The next one, I notice that enclosed in here I've got -1 to the first. So when I do the +4 times the -1, it will make that whole term a -4. And then I've got n to the third p to the third. The next one, I've got -1 being squared, so that negative gets washed out, and it's a +6. N to the second p to the second. Next one here, I've got -1 to the third power. Okay, that negative is going to hang on, -4 np. And then -1 to the fourth is a +1, so that last term is +1. It's really not too difficult as long as we are methodical with the steps, but it's real easy to mess up some of the simplifying. Be sure you're using parentheses, and be sure you're checking your exponents along the way. And our last example of the day, write an expression for the volume of the figure as a polynomial in standard form. So here they're saying the volume is pi r squared h. Well, r stands for the radius of the base, so this x minus 2 quantity is our radius, and then h is the perpendicular height to the base, so this 3x minus 4 expression is our height. So volume equals pi times our radius, x minus 2 squared, times our height, 3x minus 4. Now pi is a number, and we're going to leave that factored out. For now, we want to combine these binomials together. Now it doesn't matter what order I multiply two things together. The associative property guarantees that the product will be the same. So I'm going to move to 3x minus 4 first, and that's just for organizing. Because this x minus 2 quantity squared, we can use our shortcut for that. And let's use our distributive property. So I'm just going to use a set of brackets here. We've got x squared times 3x minus 4 minus 4x times 3x minus 4 plus 4 times 3x minus 4. And I just use the brackets because the pi out front is multiplying into everything that follows. So I want to be sure I didn't lose that. Now I got a lot more distribution to take care of, and then we can combine like terms and be done with this. Excuse me. All right, so after we distribute, we just need to combine like terms, and we will have our answer. 3x cubed minus 16x squared plus 28x minus 16. And that's all being multiplied by pi, and since that is a volume measurement, the result will be in units cubed. All right, and here's a look at your assignment for section 4.2.